All right, so this is another demo for Project Omega. One of the next steps was to figure out how to prove that we can deploy this to the cloud as true microservices into a Kubernetes type environment. So to do that, I figured at first I'd just run Kubernetes locally and then play around with a cloud implementation like Azure. So here, what you see running locally is my Kubernetes dashboard. I'm running Minikube. So to get this running, all you have to install is Minikube, which is the Kubernetes implementation, and then kube control. And once you have that running, you can run minikube start. You can get the pods here that we've created previously, and uh, we can run a command for it to open up the browser for actually running for the service that's being exposed to the host. And then here we have a minikube dashboard that gives us this nice little UI. So we can see that we have our deployments, which is the high-level concept that defines pods and a few other things kind of encapsulated in one package. But then also you can see the services, which is how you can communicate to the entire infrastructure from the outside, and also how the containers talk to each other. And then we see the pods here, as well as the replica set. So I added some replicas just to show that you can run multiple versions of things. So the core service is running 2 copies, weather is running 2, web is running 3. So that's so this diagram here is what we wanted to do, is have this microservice architecture but be able to scale individual containers. So that's what we can do. Here it is running out of Kubernetes. So everything works just like before. And then let's see. So the idea is the way that we do this is you create a Kubernetes file. We're going to have configuration by using a declarative configuration. So here we have a deployment for web, which defines our container. We're having it use our container. We're passing in the service key, which I mentioned in the other demo video, as web, and then we're defining the host and ports how to give the web container knowledge of how to access the other services. So these host names are actually pointing to Kubernetes services, which is a kind of a concept of just a way of defining network accessibility. And there's different types of service. I was going to call it a node, but that word is used for something else in Kubernetes. But the idea is that the one that exposes web is called a node port. So locally, that essentially gives access from the host machine to the Kubernetes cluster, and then specifically points to the web containers, and then you have cluster IP services that simply expose the ability for containers to talk to each other. So in this diagram, that would be like there's multiple of these load balancers, so that the services can talk to a load balancer to then get access to another service. And then of course there's a deployment for each of the services. I've just done 3, so I've done web, core, and weather. So weather and core are pretty much the same. All they have is the service key, and they all kind of need this ASP.NET Core environment variable as well. So it was a lot simpler than I thought it would be. There were a few hiccups, like I had an issue with my Docker containers. Before, I was relying on the Docker Compose build to set the ports for me. But when you build these images and push them into Kubernetes, we're not using Docker Compose, so that these ports weren't exposed. So the result was that I would try to hit the containers and I would get a connection refused with no errors, no logging or anything. But the fix was to expose the ports in the actual Docker files, so that when I build those, they actually are exposing the ports, regardless of whether or not they were spun up using Docker Compose or not. So that was that. But then I also wanted to be able to prove that I could deploy this as a standalone application. So one of the points of Project Omega is that we wanted to be able to scale from small hobby projects all the way up to giant companies with dozens of developers. So that was the Kubernetes idea. For a standalone version of this, it's very simple. It's similar to running it locally, where I have a Docker file here that is similar to the web one. that simply copies both the server app and the client app in, and then sets the necessary environment variables for the services to talk to the other services, but we're just pointing to self, so localhost. So that builds a standalone version. We have added a command to the Gulp file here for the stock Docker standalone build and Docker standalone run, which simply run Docker build and Docker run. And so we now have the ability to also run our application, deploy it to a cloud provider into one of their container services. So for Amazon, that would be like AWS Fargate has the ability to do that. And then for my test, I used Azure Container. I forgot what it was called now. Azure Container Instances. So here I have it running in production in a single container as a standalone application. Still has all the same functionality. So that's, I feel like I've proven that this model can work for both Kubernetes and microservice architecture as well as the standalone version, which is kind of the goal. So next we'll move on to some database and queue dependencies and how that would work running locally versus deploying to the cloud.